students, this is lesson 9.6. Compositions of reflections. We're going to learn how to find the composition of reflections, including glide reflections, and to classify isometries. Go ahead and do the review on the previous page, and I'll check back with you. All right, here's some theorems we're going to use. Theorem 9.1, a translation of rotation is a composition of two reflections. Theorem 9.2, a composition of reflections across parallel lines is a translation. And a composition of reflections across two intersecting lines is a rotation. So, first thing we're going to do is learn how to reflect an image across parallel lines. And remember, according to the theorem that we just talked about, we're going to end up with a translation. So in the end, our orientation will be the same. Okay. First thing I'm going to do is create a line perpendicular. I'm just going to pick a couple points here that I can label to kind of orientate myself to. And I'm not too picky about the final figure being exactly the same. But I'm going to need my compass because I need to make a perpendicular line. So I'm going to grab that and use it to create a perpendicular line. And I'm going to do it from here, from this point. Go ahead and open that up. Okay, so now I can use those 2 points. Let me make it a little smaller here. All right, and then I'm going to use those 2 points right there. And one right there. And I'm going to draw in my perpendicular line. All right, so I have all my perpendicular lines in here. Now I'm just going to measure the distance from this point to I'm reflecting it. At first, I'm going to reflect it across the line L, and then I'm going to reflect it across the other one. So the distance I need is right there, that distance. So I'm going to mark that. And I'm going to mark my other 2 distances like that also. So just kind of rough drew that in there. Now I need to measure the distances from these points to line M so that I can reflect it across line M. So this distance, and I'll duplicate that distance over here. And I'll do that with the other 2 distances. And then I drew that in so that you should notice in the end that the final picture is the same orientation as the original. It's just a translation of that. And also, one thing you might notice here is that the total distance that we went is really this distance from between the 2 parallel lines twice. So if you were to measure that distance and then do that twice, you would get your final spot for each of your points. All right, I'm going to let you try that. Check back with you. All right, in problem 2 here, what we're going to do is we're going to do the image of F reflected first across line L and then across line M. And we're going to find the center of rotation and the angle of rotation, because it turns out that when you reflect across lines that aren't parallel, that intersect, it's the same as a rotation. So what I first need to do is get a perpendicular line. So we're going to go across line L first. So I need a line, a couple points. I'll just pick this point and this point. And then we need to draw the line perpendicular, so I'm going to need a compass again. So I'm going to draw in that perpendicular line from this point to there. So that's the line that's perpendicular. So I know that the image of this point on F will be on that line. So remember, I'm reflecting across line L right now. Now I'm going to just measure that distance to line L. So close that up, and then I'm going to use that distance to find my image point there. And that's right there. I'm going to do the same thing with that other point. All right, and now I'm going to reflect it across line M. Notice I extended line M out a little bit, so I could better draw on it. And so I'm finding the perpendicular line again here. So I drew in a couple perpendicular lines there. Now I'm just going to find the distance that I need to reflect it across. And then I'll draw my two corresponding points and draw the letter F there. There's my letter F. Now I want to just answer a couple questions here. We want to know what the angle of rotation is, because a double reflection like this is actually a rotation, and what the center of rotation is. Well, the center of rotation is just P right there. So what I'm going to do is draw a line from the image point to the original point, and then just measure that angle. So you can see I drew in those two lines, and just so you can see again, those lines are going from these image points, and you move this one over just here, to my point of rotation P. And notice I'm using the same 2 points to get that angle. So what I'm wondering is, how much did that rotate? And I'm thinking in a counterclockwise direction. So if I measure that up here with the protractor, you can see that it's gone. The measurement has gone about, and it's hard to get this perfect, but about 120 degrees. And if you think about how we're drawing this, that there's a 60-degree angle here, and that we reflected twice, so we kind of doubled that angle of reflection there, and it makes sense that it's 120 degrees. So it's a 120-degree rotation and about the center P. All right, you try that. All right, in this problem, we are going to learn about a thing called a glide reflection. A glide reflection is when you have an image and you first translate it and then you reflect it across a certain line. So I'll show you how this works here. First thing we're going to do is take these points and translate them. Go ahead and put those coordinates on your grid and label them with R. So for the first thing, we're going to translate them using this translation rule. So we're going to add a to each of the x coordinates. So we're going to get -5 plus 8 is 3. The y isn't changing. -2 plus 8 is 6. And -3 plus 8 is 5. All right, then we're going to go ahead and graph those coordinates. So now we have this figure, we've translated, we really just shifted it 8 units to the right. Now we're going to reflect it over the line y equals 0, which is the x-axis. So I just need to make sure I have the same distance from each of those points across the x-axis, and that'll be my final figure from this glide reflection. And then we're just going to label those as R prime, S prime, T prime. Go ahead, you try that. All right, the last thing we're going to do is talk about classifying isometries. There are only 4 isometries: translation, rotation, reflection, and glide reflection. And you should know that if it's a translation or a rotation, the orientations will be the same. That is, the direction of the object may change. It may have turned, but it hasn't changed. And when you reflect it, your orientation is the opposite of what it started. So look at these figures below and we'll decide what type of isometry maps the pre-image to the image. So here's my pre-image right here. And if you look at A, notice that the direction is the same, which means it's either going to be, the orientations are the same, so it's either a translation or rotation. And since it's twisted a little, we're going to say that this is a rotation. And the second one, if you look closely there, you can see that the orientation has changed, and which means it's either a reflection or a glide reflection. And what I mean by that is, all right, so here's my original image, and if I slide it down a little, and you might say that's a glide, and then if I flip it, oops, wrong way, sorry. I flip it left, right, it matches that object. So that is a reflection. And the orientation is changed. Go ahead and try that. All right, there's your answers. We're up to the lesson check now. Go ahead and do that, and we'll talk about this next time we meet in class.